Hello, ladies and gentlemen. Today we are starting a set of lessons about speed, velocity, and acceleration. So the first part of this is going to be about speed and velocity specifically. And I'm sure that you can think of a lot of things that go very fast, and that's usually what we think of first when we think of the word speed. So if you had to think of some words that might describe an object in motion, certainly fast is one of the first ones that comes to mind, but there are a lot of other possibilities as well, and sometimes they describe something that is getting faster, or maybe something that is actually getting slower. Could be something that is getting closer to you or is getting further away from you. And so as you can see here, there are a lot of different options. If we define speed, we define it as a rate or as the rate at which an object moves. And in order to be able to know what that rate is, we have to know the distance that the object traveled, and we need to know the time that was taken to travel that distance. So without being able to know the distance or the time, we're not able to find the rate or the speed at which the object moved. So what are some objects that move at high speed? I'm sure you can think of some, and certainly we have things like motorcycles that move at high rates of speed, and then we have stock cars that also move at high rates of speed, of course. Not to mention the fact that we also have fighter jets that can also move at very high rates of speed. How about some things that move at lower rates of speed, that move at a low speed? This first one is one of my favorites. So it is from slow-mo, guys, for any of you who may be familiar with them. All right, but here we see a slow motion of something that actually happened at a high rate of speed. We also have, of course, snails. We know move at a slow rate of speed or a low rate of speed. And of course, anything that is in the middle of a traffic jam also moves at a very low rate of speed. All right, well, that is a lot of fun. Also fun, of course, is math, right? Well, as it happens, speed can be calculated using a formula. And so that formula is speed equals the total distance divided by the total time, or d divided by t. And so you can memorize that formula certainly, and if you are if math is one of your things, if it is if your mind works well with math, then you may be able to then manipulate that formula to change it so that you can, if you needed to, find the distance instead or find the time instead. But one tool that helps a lot of us is this lovely triangle right down here at the bottom of the page. So for instance, if we want to find the speed, which is what this formula is all about, then we are going to do the things that are not a part of the speed part of the triangle. We're going to do distance divided by time. So if we want to know speed, then we're going to assume they're going to tell us what the distance is. We can fill that in. We're going to assume that they've given us the time. We're going to fill that in. And now we have these two numbers, and what's in between them? Well, a division symbol. Whereas if you needed to figure out the distance, that means they must have given you the time and the speed, so you're going to do the operation that's between those, and that is multiplication. So distance is time times speed, or speed times time. If you needed to find the time, then that means they must have given you the distance and the speed, so we're going to do distance divided by speed. All right, so if we need distance, it's time times speed. If we need the time, it's distance divided by speed. And if we need the speed, it's distance divided by time. So I'm going to ask you to work on a few problems for yourself. We're going to start with this first one. A boat is traveling at a speed of 36 kilometers per hour. It has to travel a distance of 210 kilometers. How long will it take? I'm going to give you some time to work through the 5 questions that are here. You can pause the video if you like, and we'll come back to it in a bit. All right, so ladies and gentlemen, let's go back to that first problem actually there for just a moment. So you can see here that the question was, how long will it take? How long means that we are looking for an amount of time, and so they gave us the distance, they gave us the speed. The distance was 210 kilometers. The speed was 36 kilometers per hour. If we take 210 kilometers divided by 36 kilometers per hour, our time comes out to 5.3. The 3 is actually repeating, but we'll go ahead and round it off to the nearest hundredth. So 5.3 or 5 83/100ths of an hour. Our label, of course, for time is hours because we are measuring in kilometers per hour. All right. You can go ahead and continue on with numbers 2 through 5 at this time, and then when you have finished, you can of course show that to Miss Will. She may ask you to turn that in at that point. All right, now that we have talked about speed, let's take a look at velocity. Essentially, velocity really is the same concept as speed, but it does have one difference, and it can be kind of important. Velocity is defined as speed in a given direction. So just as before, speed depends on distance and time, but if we're going to consider it to be velocity, then technically we also have to ask ourselves, what direction is it going in? Is it going up or down or left or right or north or south or east or west, or really any type of direction that is applicable to the situation would then help us to be able to say that this is velocity. All right. So what makes the speed of these objects into velocities? Well, let's take a look. We've got some skateboarders heading down a slope, and so in this case, yes, we could calculate their speed, but in order to call it a velocity and to name the velocity, we would have to say that they're going so many miles per hour, kilometers per hour, going down, right? Perhaps for this one, it's a matter of their cars are going a certain speed, but driving north. That then makes it a velocity. Or I guess we could say to infinity and beyond if we're talking about a space shuttle. The reality is, ladies and gentlemen, that when we are talking about velocity, it can actually get a little bit confusing because even though technically in science, velocity is speed but with a direction attached to it, even scientists will often use the word velocity when what they're actually talking about is speed. They may not in that particular instance care about the direction that the object is going in. All they really want to know is the rate at which the object is traveling, which is speed, but they will often use the term velocity. So it really can be kind of confusing. You do want to make sure that you clarify to make sure whether or not, when it asks about a velocity, whether or not you should be including the direction. If you're able to include direction, if any direction is indicated or mentioned and the word velocity is also mentioned, you should probably include that direction. All right, so there is speed and velocity. Next time we're going to answer the question, what is acceleration? So we'll get into that next time, ladies and gentlemen. I hope that you have a great day.